Okay, good morning everybody. My name is Elton Duplessis. I'm the Regional Manager for Africa for the eyesight laser scanning product for Maptek. And the talk I'm going to give you today is a little different to what you've seen this morning, where everything else has been about what the guys are mining and the percentages and everything else that they're going to be getting. The talk that I've got is more aimed at when you're actually in production and auditing all of your results, so that all of these feasibility studies and everything else that have been done, you can now audit to make sure that the mining process itself is actually following and delivering on what you were expecting. So what we're going to be talking about today is just common issues facing the users of laser scan data, and then using one set of scan data across multiple departments. A problem that has been, or that arose when laser scanners were first launched, was that it was only really available to the survey department on a mine, and the surveyor would get the data in and he'd process what he could out of it, and he'd have 10 million points that he could work with, but he could only really process 1,000 points at a time. Limitations for that were computer hardware, software, and just the processing capabilities that there were around. Now, with advances in the IT field, it has allowed the developers of the software to now start taking advantage of these things, and we can now start using the multi-threading capabilities of processors. We can start using the higher graphic capabilities of some of the top-end graphics cards, and when you start adding all the extra RAM and everything else that you can, all the extra storage to these systems, you can start using these massive data sets to start giving you much more accurate results. So what we're going to talk about now is using the laser scan data and one set of data across multiple departments. So generally, the mine surveyors were the first people who identified laser scanners as a very good tool to add to what they could use to do their day-to-day jobs. It was never going to replace the mine surveyor. He still had to verify results, but what it would allow him to do is cover a much larger area in a normal day. So they would have a lot more data that they could process. And initially, what they were only using it for was stockpile volumes, dump volumes, and doing their month-end pit updates, because that's all they could do with the sort of IT that was available to them at the time. Okay, so while this was a good start, there was the scope that everybody saw this potential to actually use this data for a lot more, but they just didn't have the resource to do it. So from advances in what we could do and developments in the post-processing software, we were then able to go out and say, okay, well, what you guys can start doing now is you can start doing your toes and crests, which were, for laser scan users, a very, very difficult thing to do, because there's no timestamp on the laser scan data. And we had to develop software that would actually automatically recognize these things. So automatic toe and crest extraction became a possibility. You could then start doing spot heights, and you could start giving internal clients on the mine point grids of 0.5 meter instead of a 10-meter grid, which made your volumes a lot more accurate, made your mine, your sort of in situ pit versus your mine design a lot more accurate. You could start doing a lot more comparisons with the laser scan data. Obviously, stuff like generating contours and whatever else, which was you would have to export from your point cloud processing package into your normal mine design package, you could now start doing in all of this, and you could reduce that time it took to start delivering results to your internal clients on the mine from a surveyor's point of view. Once again, stuff like sections, where you could take these tens of millions of points, reduce it down to a few spot heights, reduce it down to contours, reduce it down to sections, and then send that data out for other people to use in packages that couldn't handle that amount of data. So this is everything that the surveyor could do, and everybody was very, very happy with it. But there was still this potential to be able to expand on that and to be able to allow other departments to get access to this data as well. Laser scanners themselves have the ability to take a digital photograph at the same time as what they're scanning points. So they'll scan 8,000 points a second and at the same time take a 72 megapixel digital photograph. And for a long time, that photograph was almost useless to anybody else, because they just didn't have anything to process it with. So what the developers then did was they then started looking at it, and they said, okay, from an internal client point of view, what other departments can start using this data? So one of the departments that came up was geology, and one of the really good things you would be able to do with it was your geological mapping. On a lot of sites, the guys aren't allowed within 10 meters of the face due to safety concerns, but they'd still have to go out there and do their geological mapping. So what is being developed is a tool that when the surveyor goes out to do his normal production scan and he's getting this data that has this photograph overlaid over it, you can now go in and the software will automatically for you extract the lines on the contacts and where you see all the features. And just by making a few clicks along that line, it will then interpolate all the points between there based on the difference in colors in that photograph. You can then take that data, and it's accurate to 10 millimeters, and move that into your other softwares from the point cloud processing package in order to do your geological mapping. From that sort of point there, if you had mapping from before your blast and mapping post your blast, especially in a coal mine situation like you have over here, the surveyor could then come in, take that data back from the geologist, work up a model, and actually make sure that they reconcile what was mined versus what was expected based on the geological mapping that was done and the model that could be created between that. And it starts giving you a lot more accuracy that can then be reported back into the system. So that was very good, and it was a very nice tool to have, and something that has been taken up by the geologists quite a lot, because it allows them to more accurately do their jobs when safety restrictions limit what they can do. We then looked at it again and said, okay, well, what other departments can start using this sort of data? And the geotechs came up quite a lot, and there were a lot of questions from the geotechnical engineers about what is it that we can start doing with this data. So we started asking them what they wanted, and we got a few geotechs in, and they started looking at the software. And one of the big things that they wanted, or one of the big restrictions that they had, was being able just to access areas where they could measure dip and strikes. You know, there were some areas that were just out of reach, or once again that they couldn't get to because of safety issues, but they still needed to measure this sort of stuff. So what was developed was a very, very simple tool where you could go onto the laser scan data, drape the photograph over, highlight some of the points and say, okay, give me the dip and strike of this one region, which was fantastic. It was a really, really good tool to use. But if you had 1,000 planes that you needed to do this on, it was a very manual process to go through this and have to do it on these things one by one. What was developed was a tool that would automatically extract these discontinuities based on the original selection from the geotech. So you could then take a mining face that you had scanned, and this could be up to 200 or 300 meters long, however long you wanted it to be, and you could make one selection of a plane and then give the software parameters of what you wanted it to work within and find everything that matched up to that plane from sort of -10 to +10 degrees. And it would then automatically, as you can see in this picture over here, highlight all of those discontinuities for you, which you could then save out as one join set, select something else that was on a different plane, and start building up this database like that. So you would then land up with thousands and thousands of dip and strike readings, and you could then start then exporting this into the other software packages in order to do your stereo nets and your rows diagrams and everything else that you needed to do. So what we then did was we looked at that and said, okay, well, there's these thousands of values that we've got, and we developed the stereo net and rows diagram portion within the point cloud processing package as well. So now you're moving from just doing your surveying and your volumes and your pit updates to doing all of your contours, all of your spot outs, doing your geological mapping, and then moving into the geotech realm, all within this one package, using one set of data that the surveyor had gone out and collected on the day. So this then became a very, very good multi-departmental tool, and something that the guys were really, really happy to use because it became affordable, and you could start splitting budgets across all of these departments to buy this tool. Another process that came up then was actual conformance, so making sure that the guys are mining to plan. And once again, it was looked at and said, well, we can use the same laser scan data to do that. And a system was developed where you could go in and you could take your mine plan, take your scan file, overlay one over the other, give it certain parameters to look at, and you would then actually be able to say whether you had overmined, undermined, whether you were mining to plan, whether everything was exactly as it should be. And the good thing about this is that you can then go on a daily basis and go back and scan this thing and look at it in the afternoon, and before you start cramming equipment from one end of the mine to the other, which adds to the cost and affects all of those values that everybody's been showing you earlier about the money they expect to make, you could then make sure that the guys, the contractors, even your own guys, are mining to plan, making sure that they're mining the area that needs to be mined, and you could do what you needed to do. From a geotechnical point of view, you could start looking at these things and making sure that guys are mining exactly the way they should, so that you don't have geotechnical issues later on that develop when slope stability starts becoming a bit of a problem. You can start making sure that people are doing their job exactly as they need to do. So all of these images that I'm showing you are very interactive, and the nice thing with these is that the surveyor goes out into the field, he does the scan, he then uploads this data to a web server. And if you don't have an on-site geotechnical engineer, but you have one that you contract out and he may be sitting in America, on the web server he can actually access this data on the same day, have a look at exactly what has been done, and then get back to the production guys on the mine and say to them, this area you've overmined, that area you've undermined, visually we can see it over here, and it's available to him on any mobile device. So he can look at that on his smartphone, on his tablet, he can look at it on the web if he wants to, and all of this information is available as soon as it's uploaded to the server, which is basically if the surveyor has a data connection with him in the vehicle, it can be done immediately, or it can be done within a couple of hours of the scan taking place and he gets back to his office. And this just makes sure that everything that we've all been shown this morning, where all of these values that the guys are expecting to get and all of the grades that they're expecting to get and all of these massive investments that have been put into the mine, the one laser scanner with the one software package actually allows you to audit all of this very, very accurately and very safely, and to make sure that you're actually getting those results that you're expecting to get. So everything that we're looking at here, like I say, all comes from one tool, from one department that gets fed out into all the other departments. And the good thing about all of this is that all of these results are available within 1 hour of the surveyor getting back into the office. The post-processing process has been reduced from days for these millions of laser scan points to literally 1 hour. In that hour, they can deliver pit volumes, they can deliver an updated pit shell, they can deliver geotech, they can deliver geological mapping, and they can tell where over and undermining has been done. So this all then adds to the value of that whole process and makes sure that no money is wasted at any point in the mining process. So if anybody has any questions for me, I know it's been a little bit different from what you've been looking at this morning, but if you do have any questions, you're welcome to come and visit us at stand 1304, and we can do a few live software demos for you if you want to. We can have a look at some of the data and answer some questions and maybe see what we can do for you. So thanks very much.